This presentation is entitled Processing XML in a Relational Database Management System. Now, XML is used for applications to talk to one another. They exchange XML documents back and forth. Now, if you look at an XML document, really, it turns out it's really a graph. So what this presentation talks about is the use of something called a soft schema to store XML documents. The way to validate XML documents today is with the use of something called an XSD document. This presentation introduces a really new and clever use of XSD documents in support of something called polymorphic queries. Now, a polymorphic query enables you to write a query in such a way that you don't care about the underlying details of the structure of an XML document. So you can write the query for a particular XML document, introduce a completely different kind of XML document, and not have to change the query specification at all.
Processing XML in a relational database management system. Information technology today has many challenges associated with it. For today's presentation, we're going to look at the challenge of interoperability, which today is restricted to standard message passing. To address the challenge identified in the last slide, we're going to look at a technology called TCSQL. In particular, we're going to look at its ability to take an XML or XSD document and deserialize it into something called a soft schema. Let's begin by looking at different ways of storing XML in a relational database system. The first approach is to store XML as table columns of type XML. The advantages of that kind of storage is navigation is very flexible using XPath kinds of navigation. Unfortunately, the queries are kind of slow. And you end up with this mismatch, this paradigm mismatch between SQL and XPath. So some of your columns, you're using standard SQL, and other columns that are of type XML, using XPath kinds of queries. Second type of storage is to take an XML document and store it in conventional relational database tables. Unfortunately, that means it requires custom queries. For every different kind of XML document, you have to write custom queries to pull out the data from the custom tables. The queries tend to be rather fast, but it exacerbates the data complexity problem, and it introduces more complexity by introducing more tables. The third approach is use of something called a soft star schema, which provides flexible navigation, very fast query, and the ability to literally write queries that can apply to any XML document. And we'll be talking more of this approach in the upcoming slides. The object-oriented paradigm can be represented as a graph problem. So here we have a class here called class 1, which has properties A, B, and C, and a has a relationship between the class definition and its associated properties. We also have another class here called class 1.1 with properties D and E. And we see a relationship here between these two nodes, an is-a relationship, meaning that class 1.1 is a specialization of class 1. Now let's look at a graph here. Let's look at what happens if we want to instantiate class 1.1. Let's look at the equivalent object graph. In this case, it would look like the following. Assuming we want to instantiate class 1.1 and we're going to call that object 1, what happens is the following. We first want to instantiate properties D and E, and then we want to look at this inheritance is a link here to inherit properties A, B, and C, which is what you see down here. Okay, now let's look at the relational tables needed to support this paradigm here. So we have the notion of a class table here, which represents the nodes of our class graph here. It's basically a name-value pair here, and we have a type column here, and legal type values. This represents basic class types here. We have a class connection table of parent-child nodes here and a connection type here. In this case, it's going to be either has-a or is-a. And then we have a transitive closure table representing the transitive closure of this class graph. and assume for a minute that this transitive closure table is automatically populated and managed whenever nodes or connections are added or deleted in this class graph. Let's look at the tables needed to support our object graph here. We have a table called object, which represents the nodes of our object graph here. Again, it is basically a name value pair with a class column here representing the kind of class that we're instantiating here, including the class properties. We also have an object connection table here, which represents the connections of our object graph. So it's a parent-child pair, again with connection type. And we have a transitive closure table associated with our object graph, and assume here also that this transitive closure table is maintained automatically whenever nodes or connections are added or deleted in our object graph here. So this whole paradigm here I'm describing here with these 6 relational database tables is something known as a soft schema. Let's look at an XML schema definition document here and the corresponding XML document here. One of the things you notice here in your XSD document, it's a hierarchy. Similarly, you look at an XML document, it also is a hierarchy. So what you can conclude, especially looking at the last slide talking about the soft schema, an XSD document can be represented as a class graph. Similarly, an XML document can be represented as an object graph. Let's look at an XML document example. In particular, we're going to look at an XML document pertaining to pharmaceutical. So here's our document here. And we have this code field here, this code tag, I should say. One of the things you can do with TCSQL is it provides an ability to import this data here into corresponding soft schema tables, object connection, and object transitive closure here. So in fact, the data in these tables I indicated earlier represents a graph here. So let's say you want to pull out all of the tags here in your XML document, the code tags. I can write a select statement here on the soft schema tables as follows. Select star from the object table where name equal code. Let's say I only want to pull out the code tags within the context of this dose administration parent here. I can write a select statement as follows here. Notice I'm using the transitive closure table here, basically saying starting from this node here, find all of the code attributes underneath here, and that's what this select statement represents. Let's look at another XML example. In this case, another XML document in the healthcare field here. So here's our XML document. Notice here we also have code information, but now the code information is an attribute of a tag called code here. So once again, as I mentioned in the last slide, TCSQL provides the ability to import this XML data into the soft schema tables here. And again, that represents a corresponding graph here. And if I wanted to pull the code information out, I can write a select statement as follows, querying from the soft schema tables here. And if I want to limit the code values to just the context of section here, I can write the following select statement. Again, it uses the transitive closure table to bound the context of the code attribute underneath the section field here. So now we've looked at 2 XML documents, both in the healthcare field here, both containing code information here. Now, let's say I would like to write a query that pulls code information from both of these documents here. Well, I could do the following, select star from object table, or name in. Now I have a comma separated list of the names of the attributes in both documents here. Now, one of the problems with this approach is, well, if I have a third document or a fourth document in the healthcare field and their code attributes are called something else, I have to hard code this comma separated list with all the different names of those attributes in all the various kinds of documents. What I can do instead is the following. I can introduce a superclass here. I'll call it vocabulary code here. And I can create an ISA relationship here to all these different kinds of code attributes here and point it to this generalized vocabulary code. I can then write a query that looks like the following here. And notice what we're using here is the transitive closure for the class table here. And we're looking at this superclass called vocabulary code. The advantage of this now is if I add new XML documents here that have different attributes referring to code, I don't have to change this query. It's always correct. This is an example of something called a polymorphic query. One of the bold claims I've made in my presentations is the ability to write a generalized query that can be executed on any structured data. So let's look at an example here. I created, just for the fun of it, a little hierarchy here entitled Tom's Social Collaborative Network. And it's broken down into family members and healthcare professionals and friends and different subcategories here. And imagine that within each of these categories is a list of people. So let's say what I would like to do is write a query that says, find all the people in Tom's Social Collaborative Network that have something to do with healthcare. So what I can do with the TCSQL capabilities is the following. I can execute a natural language processing application on any of the nodes here. So in the example here, I'm going to execute it on endocrinologist here. And what this NLP is going to do is return a set of industry standard codes associated with the ontology called SNOMED here. And it's going to return an XML document here. Well, I just demonstrated the ability to import any XML document. And so it'll look like the following here. So given a node here, I can attach the XML document returned from natural language processing here. So now what I've done is provided an unbelievably powerful ability to take any structured data here and ontologically categorize any of the names or values associated with the names of any nodes in a graph. So let's summarize what I've presented here, why all of this is valuable. First of all, I've demonstrated a very unique and powerful new use of XSD documents in support of this notion of polymorphic queries. Secondly, I've demonstrated via this use of soft schema tables the ability to not merely query, but to be able to compute across different structured data domains. Third, I've demonstrated the ability to categorize any graph node name or value within any domain context.